Hi, freshman biology. Today you're going to be taking notes over passive transport and the movement of materials across the cell membrane. You need to have your notes out, piece of paper, pencil, and I expect all of these notes to be done with a summary for when we return. So, cell membrane, passive transport. Passive transport. Go ahead and title your notes that. And at any point in time, if I move too quickly, feel free to pause the video, and then you can always scroll back on YouTube or jump ahead if you've already seen this portion. So, passive transport. Diffusion, and we are going to see all of this on your test. It's a very, very big concept. We've talked about it a little bit here and there, but we're going to see it all over the place. Diffusion is the movement of solutes from a high concentration to a low concentration. High concentration to low concentration. So in this picture we have all of the red molecules on the left, and we have no red molecules over on the right. So we can say we have a high concentration of the red molecules over on the left-hand side. So these red molecules are going to move from a high concentration into the low concentration, and eventually they will equally spread out and meet equilibrium. This whole process requires absolutely no energy and is going to continue until equilibrium is reached. Now, equilibrium, its root is in equal, which means the same. We're going to have the same amount of molecules all over the place. However, these molecules are still going to be moving. That is a big misconception. I see it every year. Even though diffusion will always go towards equilibrium, once those molecules are equally spread out, we still have movement of those molecules. It's similar to if you've been sitting in a car for a really long time. Even though you may not have the windows down, you can still tell that there is air moving throughout. So one of the examples that I will be referencing in class is my wallflower I have right over here. This is plugged in over here by my desk, and it smells really nice. I can smell it really well over here, but if you sit over at table 8, over in the far corner of the classroom, chances are you can't smell it very well. So these molecules diffuse from a high concentration in the corner of my room to a low concentration over in the opposite corner of the room. So that is diffusion. Okay, so then we have to talk about concentration. This is solutes versus solvents. Solvent is the solution itself, and the solute is the stuff inside of it. So once again, down here we have a high concentration of the solute within the solvent, and it moves from high concentration to low concentration until it reaches equilibrium. Once again, these molecules are still going to be moving back and forth, even though they've reached equilibrium, but the concentration levels are going to roughly stay the same. So concentration, it doesn't mean like focus here. It just means how much mass is in that area per volume. The amount of volume is going to determine whether something has a high concentration or a low concentration. A really good example is if you have 30 students in a really small classroom, that is going to be very concentrated. You're going to have a lot of students per area. However, if you take those same 30 students and put them into the auditorium, it is not going to be very concentrated because it's got a lot of space, the students can move out. So I'm sure you can think about your different classes in that not all of your class sizes are the same. I'm sure there's probably a math class with a lot of students in it, an English class with a lot of students in it, whereas our biology class does not have as many students in it. So concentration just means how many things per area. So passive transport. The word passive means no energy. We hear this term a lot, especially when we are talking about passive aggressiveness. If you're going to be passive aggressive to somebody, it does not take any work. You leave them on read, you don't text back, you don't answer any of their phone calls, you give them the cold shoulder, you just reply K. All of these things are very passive. They don't require much work for you. You're mad at them, but you're not going to put any work into letting them know it. So passive transport, no work, but there's still transportation happening. So it is the movement from high concentration to low concentration. This is diffusion. But diffusion does not require any energy. It happens all on its own. I plug in my wallflower just to heat up the oils inside, because when the oils get heated up, it's going to make it smell better. It's similar to how when someone at home is cooking something, you can smell it more the warmer it gets. So I don't have to put in any work in order for these oils to get spread out. There are like the diffusing reeds where you can have like a jar with oils and there are like these little sticks that come out of it, and then you can smell the oils based off of that. So in general, passive transport, absolutely no energy goes into it. The cell doesn't have to do anything. You have 3 examples of passive transport that you have to know for your test. You have simple diffusion, which is just the regular type of diffusion. My molecules from the wallflower go from one side of the room to the other. We have facilitated diffusion, which we're going to talk about in a little bit, and osmosis, which we will also be covering here. But the main concept, none of them require any work or energy. So, passive transport, no energy. We're going to be redundant here. You guys have already written this down, but I'm saying it again so that you know that this is the thing. Diffusion, simple and facilitated, we have it on your test, and osmosis. Once again, you guys should have written all of that down. But the important thing is, all of the movement here is controlled by concentrations. If we have a lot in one area, all of those solutes are going to want to spread out everywhere else. So, osmosis is the movement of water from an area of high concentration to low concentration. Osmosis is very important because it is just water. We see this with your cells all the time. It is so, so important for you. That's why we talk about like staying hydrated. We end up seeing osmosis work a ton with our kidneys, and this is what changes the color of your urine. So, osmosis, no energy is required. And we have 3 types of solutions, and I know I've got this like really awful like thing that I've drawn on there. I apologize about that, but you guys will adapt and overcome. I know you will. So hyper, that means over. So hypertonic, we have a really high solution, we have a really high solute compared to what's inside the cell. So here we're going to be looking at the actual solution surrounding the cells. That is the easiest way I can think of to present that information to you. If you Google osmosis, hypertonic, isotonic, hypotonic, it will get confusing, so make sure that you stick to what I have on my PowerPoint slides because it all depends on your perspective. So hypertonic, we have way more stuff on the outside of a cell. Iso means the same. So isotonic solutions, they have roughly the same amount of stuff on the outside of the cell as there is on the inside. And then hypotonic means that there is a very low amount of solute on the outside of the cell compared to the inside of the cell. So hypo is under or low. Think about the rhymes. Hypo is low. Hyper is over, it's a lot, and then iso is going to be the same. So on your test, you will need to know all of this information. An isotonic solution, so we have the same amount of stuff on the inside as there is the same amount of stuff on the outside of the cell as there is on the inside of the cell. Because of that, our cells are going to remain the exact same. So here we have pictures of red blood cells under the electron microscopes that we talked about a couple days ago. So these red blood cells stayed exactly the same because they were in an isotonic solution. There's the same amount of stuff on the outside of the cell as there is on the inside. We also have hypotonic solutions, which is when there's very little stuff or solutes on the outside compared to on the inside. The most common example is going to be pure water. If you have pure water and you put a cell inside of it, the cell is going to fill up with water. The water is going to diffuse inside of the cell, and it's going to blow up like a balloon, and sometimes it will pop just like a water balloon. So hypotonic, the cell will swell, but I have another rhyme for you. Hypotonic has low solute and will grow. So hypo, low, grow. If you can remember those 3 words, hypo, low, grow, you're going to be set. And finally, we have hypertonic solutions, because hypertonic refers to a lot of solutes on the outside of the cell. then that means that the water is going to rush out of the cell and that the cell is going to shrivel up from all of that water kind of deflating it. So our beautiful cell membrane, oh my gosh, it is wonderful. I believe next week we will look at playing with bubbles to replicate a cell membrane. So our function of the cell membrane is going to be to regulate what comes into and out of the cell. Tons and tons of regulation. We want to make sure that we are getting in the nutrients that we want and we are keeping the rest out. This is a concept called selective permeability. I am being selective, or I'm only selecting a few things to pass through the cell membrane. So permeable, it means that some things can get through. So selective permeability, only a few things are able to get through. You need to know that for your test. So if you didn't catch what I said there, I would rewind it and listen to what I said about what selective permeability is. We also have your cell membranes communicating to each other. Protection and support, the cell membrane is there to make sure that the cell is nice and defined. It helps give a little structure to the cell so that the cell can do its job. The cell membrane is made up of something called a phospholipid bilayer. So phospholipids, that's a throwback to the last chapter that we had. Phosphate and a lipid is a phospholipid. And then bilayer, bi means two, so that means that we have two layers. And you can actually see it really well here. We've got all of these like tiny orange circles on the top and then on the bottom, and then we've got like these little sticks. This is one layer, this is the other layer. So we have those two layers coming together to make the cell membrane. And we have this idea of the fluid mosaic. It means that the membrane is constantly moving, it is constantly kind of floating around. But it is embedded with some other molecules in order to give it some stability, in order to give it a little bit more of a function, especially with that selective permeability. So those phospholipid molecules, they end up coming together with proteins and carbohydrates in order to allow for other things to pass through the cell membrane. So it's been a while since we talked about phospholipids. You need to know what a phospholipid structure is. So take your time on this slide. We have a polar head. Now you might recall we talked about polarity a while ago with water. Water is polar. That's very, very important. And as a result, water is able to dissolve other things that either have a positive or negative charge. So this phospholipid, the head is polar, which means that it is hydrophilic. Hydro meaning water, phil means to love. So if you think about like Dr. Phil and all of his shows, they're always talking about like how can we get to the root of this problem so that we can love each other again. So phil means love, hydro is water. This entire thing means that the polar head, which we can see up at the top, means that it is very attracted to water, and that water and the polar head are going to come together quite often. Now, the tails, which we can see over here, those are going to be nonpolar, which means that they hate or are afraid of water. There's something called a phobia. If you have a phobia of something, it means that you're afraid of it. So I have arachnophobia. I am terrified of arachnids, which is spiders. I hate them. So nonpolar means that it does not like water. It is hydrophobic. So it will do everything in its power to get away from the water, which is why in the end here, when we look at it, the tails, which are going to be these like light orange little sticks in the middle, those come together, and the heads that love water are going to be on the outside, because we have water on the inside of your cell and we also have water on the outside of your cell. So cholesterol. Cholesterol, it's these like tiny little chains of hexagons in there. It ends up stabilizing the membrane by keeping those nonpolar tails from sticking to each other. It makes sure that it has like the right consistency when it gets too hot and when it gets too cold, so it keeps the cell membrane from freezing at really low temperatures. And then we also have carbohydrate chains. Go figure, they're on your test. These identify chemical signals from the outside of the cell. So this is actually the inside of the cell, and this is the outside of the cell. We have water on both sides, which is why the hydrophilic heads are going to be on the outsides and on the inside of the cell. But on the outside here, we have like these little chains that stick out. These are carbohydrates. And a while ago, I